Hi, so in this video we're going to talk about pressure and particularly we're going to focus on pressure from gases, so gas pressure, okay? So if you imagine what exactly is the concept of pressure, uh, imagine you have a little container out here and this container is filled with gas, so I'm just going to draw the little gas molecules all over the container. And then what's going to happen is these molecules that are close to the walls of the container, they're going to try to exert pressure against the walls. Okay, so they're going to, when I say pressure, they're really going to try to force against the walls. Why? Because these molecules are in random motion. Okay, so these molecules are in motion. The motion is random. And as a result of that, they're going to push against the walls, okay, with a certain force. Okay, so we're going to say, let's talk about this wall on the left. There's going to be a force that the molecules are going to push against the wall with, okay? And in order for us to understand the force, okay, for every small little bit of wall, we have to define what cross-section we're looking at, okay? So let's say we have a certain area, okay? So if we kind of make this, right now we're looking at this in 2 dimensions, but really, we could make this a 3-dimensional system because that's really what it is. So if we had a cube, then let's say we're trying to understand the pressure along this wall, this side wall out here, okay? So then if we know the area of that wall, then we can take this force that's with which all the molecules are hitting that wall, and we divide that by the area, and that gives us the pressure. So really, the definition of pressure is force over area, okay? So now, the next thing we need to understand is what are the units of this pressure, okay? So the first type of unit we'll look at is SI units, okay? So the SI unit of pressure derives from the SI unit of force and the SI unit of area. The SI unit of force is actually newtons, and the SI unit of area is meter square, okay? So there's a Newton per meter square. So 1 Newton, which is represented with a capital N, per meter square is equal to 1 Pascal. That is the SI unit of pressure. And Pascal can also be denoted as 1 PA. Capital P, small a. Okay? So that's one of the units of pressure. Now, what is more common is to use units of pressure that are in atmospheres. So basically, the atmosphere, if it's kind of, you can think of it as a body of gas, it's actually sitting on us, okay? And when it's sitting on us, it exerts a pressure on us. What exactly is that pressure? That is 1 atmosphere pressure, okay? So what I'm going to do is, I'm going to transition to all the different units of pressure, and then we'll wrap up the video from there, okay? So to understand what atmospheric pressure is, we need to just take a look at this setup out here. We have a tub, and this tub is actually filled with mercury. And if we put a little column in the tub that is closed out here, okay, what's going to happen is the atmospheric pressure is going to push down against this, okay? So there's going to be a pressure pushing down against this, and it's going to force the mercury up this column, okay? And turns out, when the atmospheric pressure is 1 atmosphere, ATM is atmosphere, that actually pushes the mercury up the column to 760 millimeters, okay? So 1 atmosphere, 760 millimeters of mercury, okay? And then turns out, the scientist who kind of invented this setup to kind of determine pressure, his name was, I'll write his name out here, Torricelli, okay? And so, I believe there's 2 R's in Torricelli, so Torricelli. And so turns out, in honor of that scientist, 1 millimeter mercury is the same as 1 torr. So that unit comes from the scientist who invented, who tried to figure out how to measure the pressure. Okay, so 1 atmosphere is equal to 760 mm mercury. 1 millimeter mercury is equal to 1 torr. Okay, and then we already mentioned that the SI unit of pressure, so the SI unit of pressure is 1 Pascal, which is 1 Newton per meter square. Now we have to compare how does Pascal compare to millimeters mercury and then atmospheres, okay? So it turns out 1 atmosphere is equal to 101,325. So Pascal. So a Pascal is very, very small compared to an atmosphere, okay? So that's the relationship between atmospheres and Pascal. And then there is another unit of mercury, another unit of pressure that you will encounter from time to time. It's called a bar, okay? A bar, okay? And 1 atmosphere is equal to 1.013 bar, okay? So 1 bar is approximately the same as 1 atmosphere, okay? Now, if you want to get very technical, then it's 1.013, okay? And that's pretty much what you need to know in terms of pressure and its unit.